Okay, so we're going to be reviewing for the quiz on dividing polynomials and factoring and finding zeros. So we're starting off with problems that are just asking you to divide. So the directions here say find the quotient for each problem using any division method, and that means that you can use synthetic division or long division. Okay, and then it's saying put your answer in q of x plus r of x over d of x form, and that's just reminding you that when you have a remainder that you need to put it in a fraction over the divisor. So let's take a look at the first problem. Okay, so if you've noticed first, let's decide which problems we're going to use synthetic division for and which problems we have to use long division for. So if I'm looking at this, I'm going to look at the divisor number. So in this case, I have an x minus 6. In problem number 2, I have a 2x plus 12. Problem number 3, x minus 3. Problem number 4 is x plus 2. 3 of these I can use synthetic division for, and in this case that is problem 1, problem 3, and problem 4, and that's because each of these problems does not have a number in front of the x value, right? Problem number 2, if there has this 2 here, and so we can't use synthetic division in its current form. We could divide by 2 and try to do that, but we're going to do long division on that one. Okay, so this first problem, I can set this up. Remember, we're going to say when I set up my synthetic division symbol, the number that goes on the outside is what turns the divisor into 0. So in this case, that's 6. Okay, and then I'm going to list the values that are the coefficients of everything in this expression, and I'm not going to forget that because in this case there's an x squared missing, then I need to put in a 0 for the x squared. So it's 1x cubed, 0x squared, negative 44x, and a positive 48. Right, and now I'm going to do synthetic division by bringing down my first term, okay, multiplying the 6 times that first term, and the answer goes in the second column. I'm going to add down the second column, okay, and I'm going to multiply again. 6 times 6 is 36, okay, and I'm going to say what when I add together negative 44 and 36, it looks like I get a negative 8, okay, and then I'm going to multiply again. 6 times negative 8 is negative 48, okay. I'm going to add down the column one more time, and in this case I have a 0 remainder. Right, that last number is always going to represent the remainder. So don't stop here. Make sure that you actually write the expression that this represents. This is basically saying that the first term is, I'm sorry, the end of the expression, like the 48, is the minus 8. The x value is the x to the first value is the 6, and the x squared value is the 1. So if I write this expression, I'm going to call it x squared plus 6x minus 8. Okay, and this is done. Okay. I know that in your brain you might be thinking I need to start factoring that and trying to set it equal to 0 and solving it. Okay, all these problems are asking you to do is divide, and so we're going to stop right there. We did the division, we have the new expression, we're done. Okay, problem number 2 is a long division problem. Okay, so for problem number 2, we're going to, because of that 2 value, have to put use the long division symbol instead. Okay, we can't do the shortcut with synthetic. Okay, so in this case, 6x cubed plus 38x squared, okay, plus 10x minus 12 goes on the inside, okay, and I'm going to do a quick check on this and make sure that I'm okay, and in this case it looks like I am. I didn't skip anything along the way, so there was no need for a 0x. Okay, so the goal with long division is I need to turn this 2x, the first part of the divisor, into the 6x cubed. So if I'm figuring out how do I turn 2 into 6, well, that's with a 3. 2 times 3 gives me 6. X turns into x cubed by multiplying by an x squared. So I'm going to go above this x squared term, and I'm going to put a 3x squared. Okay, and I'm going to multiply. When I multiply 3x squared times 2x, I get 6x cubed. Okay, that's what I was trying to make happen. That should happen every single time that that first column matches. 3x squared times 12, okay, would give me 3 times 12, 36x squared. Okay, do my first. Remember, this is a subtraction. I'll get a cancel, and it looks like I get a 2x squared here. Okay, I'm going to bring down my next term, which is the 10x. Okay, I'm going to do the same thing again. So I'm going to say I need to turn a 2x into a 2x squared. Well, the only difference between these is this bottom one has an extra x, so that's what I need to bring into the problem. So x. Do another multiply. Okay, so I'm going to do 2x squared. Okay, x times 12 is 12x. Okay, I'm going to subtract again. Okay, I'm going to have to move my answer over here. Okay, so when I do 2x squared minus 2x squared, I get my cancel. Okay, when I do 10x minus 12x, it looks like I get a 2x. Or, I'm sorry, negative 2x. Okay, And then I'm going to bring down my last term. It looks like a negative 12. Okay. And now I'm going to do the same thing. I need to turn 2x into negative 2x. Well, to turn a 2x into a negative 2x, I got to put a negative 1 up here. And I'm going to do my last multiply. Negative 1 times 2x is negative 2x. Negative 1 times 12 is negative 12. And I'm going to do one more subtraction, and in this case, my remainder is 0. So the answer to this second problem is this expression up here. When I divided this big cubic 4-term polynomial by 2x plus 12, I end up with 3x squared plus plus x minus 1. Okay. Problem number 3 and problem number 4 are very similar to problem number 1, so let's go through those a little bit more quickly. So I can use synthetic division because of the x minus 3. So I'm going to put a 3 on the outside. I just have more terms in this one because it's next to the 4th power problem. So I have a 1, a negative 3, a 5, a negative 25, and a 33. And as I was writing those, I was just scanning the problem and making sure I counted down 4, 3, 2, 1, nothing at the end. I didn't miss any terms, and that's good. Okay. So now I'm going to say 1. When I do my first multiplication, it looks like I get a 3. When I add down this column, I get a 0. 3 times 0 is 0. When I add down the third column, I get a 5. 3 times 5 is 15. Okay. Negative 25 and 15 is negative 10. Okay. 3 times negative 10 is negative 30. One more add. It looks like I got a 3. Okay. So here's my answer. We got to be careful with how we write this. Okay. So again, I'm going to count backwards. This negative 10, remember the 3 is the remainder. So negative 10 is like the end of my expression. So this would be the x to the first, x to the second, x to the third. So when I write my answer here, I'm going to say this is x to the third, right? Because it's 1x to the third. I don't have any x squareds, so I have a 5x and a minus 10. And this is where this whole r of x over d of x is going to come in. I'm going to say I have a positive 3, so I'm going to use plus. 3 is my remainder. That's the r of x, okay? And my divisor was the x minus 3, the thing I divided by. That goes on the bottom of this problem. Okay, so I would say my answer is x cubed plus 5x minus 10 with a remainder of 3 over x minus 3. Okay, last problem. Let me get rid of the stuff from the one above it. Took up a little bit too much space. All right, let's do this one. Okay, so it looks like I have x to the 4th, x, and a minus 3. I can do synthetic, so I'm going to use a negative 2 on the outside. Okay, and I'm going to put 1 for x to the 4th. I don't have any x to the thirds. I don't have any x squareds. I have 1x, and I have a negative 3. Okay, so let's do our long division. Let's do our synthetic division. Okay, 1. When I multiply, I get a negative 2. Add down the column, I get a negative 2. When I do negative 2 times negative 2, I get a 4. Add down the column, still 4. Negative 2 times 4 is negative 8. Okay, add down the column, it looks like 1 and negative 8 is negative 7. Okay. Negative 2 times negative 7 is 14. I'm going to add down the column, and it looks like I have an 11. Okay. Oh, let me fix my mistake. I was looking for it. Nope, no mistake. I'm good. All right. So it looks like with my remainder, I have, again, counting backwards, this is negative 7. That's x to the first. That's x to the second. That's x to the third. So it looks like I have x to the third minus 2x squared plus 4x minus 7. And I have a remainder again, 11 over x plus 2. Okay, so it looks like I have a remainder in that problem. Okay, and so we are good to go. Okay, with our 4 division problems. Okay, so let's take a look at the next problem, which is just asking us if we did our division problem and we know what the remainder is, we can kind of work backwards and find that a value. So this is a synthetic division problem. This is no different than anything else that you've done. Okay, I'm giving you an x plus 1 to divide by, which means I'm going to put a negative 1 on the outside. Okay, and on the inside, I have coefficients of a, 5, and 7. I'm not going to do anything different in this problem that I did in any of the previous problems that we've done so far. Okay, we are still going to go through the synthetic division exactly the same. I know that the a might be throwing you off a little bit, but we're still going to proceed normally. Okay, so the first thing I'm going to do is I'm going to bring down the a. Okay, so we're going to say if I bring down the a, and do my first multiplication, I get negative 1 times a is negative a. I place that in the next column. Here's where you have to be careful. Now I'm basically saying add down the column. I'm saying add together 5 and negative a. Well, 5 and negative a would be 5 minus a, or negative a plus 5, however you want to write that. Okay, and then I'm going to do another multiplication. Negative 1 times 5 minus a is negative 5 plus a. Okay, so when I multiply something by negative 1, all it essentially does is switch the signs. Okay, now I'm going to do the same thing again. Okay, I'm going to do negative 1. I'm sorry, I'm going to add down the column. 7 and negative 5 is 2 plus a. Right, that's all I got there. So here's what I'm basically saying. The remainder of this expression, 2 plus a, okay, should be equal to 33. I told you what the remainder was. The remainder was 33. So this expression, 2 plus a, represents the remainder. If I subtract 2 on both sides, it looks like the a value. What is the value of a? Well, the a value is 31. Okay, and I'm done. Okay, so in this case, I just did exactly synthetic division. I just had some algebra in my problem, and I got an expression that represented the remainder. Okay, the remainder is equal to 33, and I found a. Okay, problem number 6 and problem number 7 are just wondering. They're asking the question, is x minus 8 a factor? We don't actually have to do the division. We don't have to tell them what if the remainder is. If there's a remainder, all we have to say is yes or no, and our work is going to explain why that's true, right? So we have the remainder theorem, and what the remainder theorem says is that if you plug in this case, an 8, right? What makes they call it the a value here, right? If I put this in x minus a form, the a value is an 8. If I went to this expression and I plugged in an 8, okay, I'm not going to show you all the work for this one, okay, but essentially what happens, okay, if I plug in an 8, is that everything is going to cancel here, and my answer is going to be 0. Okay, if I plug in an 8 here, right, x to the 4th, x to the 3rd, x squared, x, all of them were replaced with an 8, and you simplified it correctly, you're going to get a 0 to come out that. And what this means is that the remainder, okay, of this division problem is 0. Okay, so the remainder theorem says if I plug in 8, I will get the remainder back, and in this case, I got a remainder of 0. Okay, there's another theorem called the factor theorem, and what the factor theorem said is if the remainder is 0, like it is in problem number 6, okay, if the remainder is 0, then x minus 8 is a factor. And so that's what we're going to say in this case. We're going to say yes. Okay, yes, x minus 8 is a factor because, okay, and again, when you do the problem on a quiz or a test, you're going to want to plug in and show me the work. You're going to actually say 3 times 8 to the 4th minus 24 times 8 to the 3rd. You're going to want to show me, okay, that this is what goes into the problem, okay, and then actually simplify all of these parts, okay, so that you can get your answer and show me that all of this simplifies and gives me a 0. Okay, so in this case, this was supposed to be an 8. Okay, so the same thing's going to be true for the second one, right? I can plug in a negative 1, and this one's a little bit more straightforward, so let me show you this one. Okay, negative 1 to the 5th plus negative 1 to the 4th. Notice my parentheses. Negative 1 squared, okay, plus 1. Okay, I don't need to put in the x cubed that's missing. It doesn't matter in this case. We're just plugging in and simplifying. So in this case, negative 1 to the 5th is negative 1. Negative 1 to the 4th is 1. Okay, negative 1 squared is 1, but I'm saying subtract that, so I'm saying minus 1, and then I have a plus 1 at the end. So if you notice what happens, negative 1 plus 1 is 0. Minus 1 is negative 1, plus 1 is 0 again. My remainder is 0. Because my remainder is 0, I'm going to say that x plus 1 is a factor. Okay, so here's just a side note about these problems where I'm asking if something is a factor. It is entirely valid for you to just do the division. If you wanted to do synthetic division on this problem and actually do the division and show that when you do the division that the last value is 0, that's an entirely valid way as well. The remainder theorem is here to make our life easy so we don't have to do division, but if you want to do the division, that's entirely okay, and that would be a valid way of showing that x minus 8 or that x plus 1 is a factor.